patience. Oh, no worries, Alyssa. All right, so this is the reminder Class Connect sessions are recorded and distributed for learning purposes listed here. As always, be respectful, appropriate, and participate. Please don't share personal information like contact info during the class for your own security reasons. We are in the April 2nd attendance ticket. Again, just get me some green checks. Let me know that everyone's able to open those. Just want to make sure that no one's having any issues getting that open. Password is in the chat box right beneath the link. Looking good. Awesome. Seeing some more green checks. Love it. All right. So guys, we only have, sorry, today is not Monday. Today is Tuesday. I guess I forgot to circle the correct day. Today is Tuesday though, April 2nd. Did you guys have a good April Fool's Day yesterday? Anybody play any good pranks or get pranked? Ooh, do we do that anymore? I feel like once I became an adult, I stopped doing that. So yeah, what happened? Oh, you got pranked, Nate. Oh no. How did you get pranked? You told your mom you failed all your classes. Oh my gosh. I'm sure your mom had a heart attack, Alyssa. Oh, you pranked your dad, Ireland. What did you do? I want to hear. You guys are funny. Keep typing in the chat box, but let me go over these announcements really quickly. So there are only 6 days left of quarter number 3. It is ending very soon. So today we are actually doing a lab. It's a very, very easy lab to get done. So you want to make sure that you get that up and done today. Bunch of social media kept getting you confused, right? I feel like I heard about like stores closing yesterday and stores opening and crazy products. April Fool's Day is always fun on the internet, right? So today we are going to be working on a lab. Tomorrow we do have a game day, and then Thursday and Friday we are working on your final exams, which your final exams are the last assignments of the quarter, which means that next week we still have 3 more days of school, but next week you'll have some days to make up any of your missing work. Give me a smiley face if that makes sense. So Friday will be your last assignment, and then next week we still have school, but you have time to make up anything that you need to. Ireland, you said you put clear wrap on the door and you thought it was a dump break. Oh no, that's funny. I love it. All right, cool. So let's take a look here. So today, again, is Tuesday the 2nd. You can see, again, we only have 6 days left: Wednesday, Thursday, Friday. Friday is our last assignment. So that means Monday, Tuesday, and Wednesday, you do have time to make up anything that you need. That'll also give you time to make up time in your other classes as well. In our live classes, I'll tell you a little bit about what that'll look like. You'll come in, I'll check in with you, we'll go over anything that you need to, and then I'll give you the password and you'll be able to go. Smiley faces if that makes sense. For Monday, Tuesday, Wednesday. So Monday, Tuesday, Wednesday, we won't have formal lessons, but you should still come so that you can get your attendance points for those days. Okay, so remember, last day is on next Wednesday, so courses will be closing at 11:59 in about a week, so it's going to go by quickly. All right, so this is our last unit. We've been talking about electricity. Dorian, not necessarily. A lot of times you do have the second part of the class the next quarter, so most of you will probably have me again next quarter for chemistry, which is the second part of our course, but some teachers don't have a second part, or you might already have credit for a second part, depending on if you transferred in. So it totally depends. But yeah, hopefully you can figure that out. You can always email me and I can let you know what your classes are for next quarter as well. You guys are supposed to be able to have access to that info, but I don't know exactly how that works. So email me and I can let you know what next quarter's classes are. Okay, so we've been talking about electricity and magnetism. You talked a little bit about circuits on the Friday recording before we left for spring break. So let's go ahead and jump into our lab for today. So we're going to demonstrate electricity, magnetism, and how they are related today, and we are going to complete the 9B lab. Okay? So our question today is, how can we convert electrical energy into mechanical energy? Remember, mechanical energy means the energy of motion, right? The ability to move. So how can we take electricity and make something move? Which we talked about at the start of class. We talked about electrical appliances, and electrical appliances do exactly this, right? Think about a blender, right? Which way does a blender move? Tell me in the chat box. What does a blender do? Do any of you use blenders? Tell me in the chat box. What does a blender do? Yeah, it mixes and crushes, right? So it spins, right? So that's motion, right? So we're able to plug it in, get electrical energy, and from that electrical energy, we are able to make it begin spinning, make it begin moving. Give me a thumbs up if that makes sense. Give me a thumbs up if that makes sense. That's what we're going to be taking a look at today, is how do we do that? Cool. Okay, so all of those things that we talked about at the beginning of class, right? We talked about fans and computers and blenders, right? And hair dryers. All of those things have electric motors because all of those things have little things that spin inside of them. Think about your computer, for example. If your computer gets really, really hot, what turns on in your computer? Tell me in the chat box. When your computer starts to get really, really hot, what hopefully turns on? Yeah, a fan, right? And a fan is spinning, right? So that fan uses a motor, okay? So an electric motor is when we have these wires that get rotated around and they're powered by a magnetic force kind of interacting with an electrical force, okay? So we're going to take a look at how this happens. So the reason that this happens is because we actually have electricity that gets turned into a magnetic field. Remember how before spring break started, think all the way back, remember I told you electricity and magnetism are two sides of the same coin, meaning one of them can actually make the other type of thing, right? So electricity can actually make magnetism and magnetism can actually make electricity. Give me a smiley face if that makes sense. Okay, thinking really, really far back. Remember, they are related. They can actually cause each other. Okay, so we can actually create a magnetic field using electricity, and that magnetic field that we create can actually interact with another magnet and start spinning. Okay, so we're taking electrical energy from like a battery or from an outlet, and we're turning it into spinning motion, which is mechanical energy. Okay, so let's figure out how this works. Okay, so here's what's going to happen. Remember that when we have an electric current going through a wire, remember that it does actually experience a tiny magnetic field. Okay, so if we coil up a wire, then it actually itself becomes a tiny magnetic field. And if you take that tiny magnetic field and you put it between two real magnets, then think about north and south and south and north and north and north and south and south. Because of these interactions between these different poles of the magnet, it's going to force it to move in a circle, forcing it to spin. Okay, give me a thumbs up if you're beginning to understand that. Okay, so we create a magnetic field using electricity, and then we stick it in between a real magnetic field from a real magnet, and those two interacting cause spinning. Okay, think about this. Remember again, if we have a north pole next to a north pole, what happens? Does it attract or does it repel? If we have a north pole next to a north pole, is it going to attract or repel? North and north, are they going to attract or repel? Remember, likes repel, opposites attract. So a north and a north should do what? Should they attract or should they repel? Yeah, north and a north pole should repel, right? And same thing if you had a south and a south, right? They're the same, so they would also repel. And if you have opposites, north and south, then they attract. So all of those little interactions that you see here literally cause this little coil to begin spinning because norths interact with norths, south interacts with south, and north interacts with south, causing it to spin. Okay, so let's go ahead and take a look at that. Okay, so I'm going to actually go ahead and teach you guys how to make a motor. So in order to make a motor, you need a D battery. Okay, how many of you have one of these probably in your house at some place? Okay, so this is really easy to get, right? The battery is really easy to get. You also need some paper clips. Okay, and then you need a magnet. The stronger the magnet, the better. So if you can find what are called neodymium magnets. All right, so let me see, neodymium magnets. You can get them off of Amazon and stuff. And then you also need copper wire. So the type of copper wire that you want is going to be called AWG magnet wire. Let's see here, 24 AWG. So 24 gauge magnet wire. And it's just a copper wire. It's really thin, okay? I can send you the link to Amazon here. Okay, or if you want to, because I know an entire roll of this might not be realistic unless you're making lots of motors, but if you want, you can always email me and I can literally just put some in an envelope for you and mail it to you. So just email me if you want to be able to make this on your own. Okay, smiley faces if that makes sense. If you want the wire, all right, I can email that, or I can physically mail that to you. Cool. All right, guys, so here's what's going to happen. In order to make a motor, what you need to do is you're going to take where are my other paper clips? Sorry, my daughter stole my paper clips, as always. She put those. Hold on, guys, 1 second. Okay, cool. I found some. All right, so what you're going to want to do is you're going to want to take your paper clip. Okay, you're going to have 2 of them. And what you're going to do is you're going to actually take the small inner part, okay, and you're going to actually twist it so that it kind of makes a tiny, tiny loop right here. Okay, do you guys see this tiny little loop? Give me a smiley face or a thumbs up if you see that tiny loop right there. Okay, so it creates a little tiny loop. And you're going to do that with both of them. So you want it to kind of be straight with that little loop in the center. If you pull it the wrong way, you won't see the loop. So make sure you pull it the right way. Okay, so you do that with 2 of them. And so you end up with 2 of these that have those little loops in the center. Okay, so then what you want to do is you want to grab your battery, okay, and you're going to actually tape these loops to the metal parts of your battery. You want to make sure that the metal is exposed and that the metal paper clips are actually touching that metal on the battery so that it can conduct the electric current. Okay, so I'm going to go ahead and actually tape these onto each end. All right, so here's taping it to the positive end. All right, and you want to line it up so that the little holes are opposite each other. Okay, so they should be directly across from each other. Okay, because we're going to be hanging something from those little holes. All right, so here we go. I'm going to make sure that they look kind of symmetrical, look like a mirror image of each other. All right, maybe move that a little bit. Okay, so now you have this and it looks like this. Okay, thumbs up guys if you can see that. If that makes sense, right? They're lined up right next to each other, in line with each other. Cool. All right, now the next thing that you need to do is you just need to stick a magnet in between the 2 paper clips. So my magnet is sticking in between the 2. So I really recommend these Energizer ones because, right, they're magnetic so that you can actually stick a magnet to them. If you don't have a magnetic D battery, you can just tape it to it. Just fold over some tape and actually tape it onto there. Okay, now the last thing that we need is we need to create this, okay, and this is the part that's actually going to spin on our motor. So the way that you do this is you actually take some wire here, okay, so we're going to take some of our wire, right, and I'm not going to take a whole bunch of it, right, so maybe like 8 inches of wire, okay, and then you're going to take a marker and just wrap it around the marker, okay, nice and neat, right, so we're going to wrap it around the marker like this, okay, and then slide it off. Okay, and you kind of want two long ends if possible, right? So you kind of want an end right here, okay? And you're going to actually fold that over so that, fold it through the center and over so that it kind of holds the loops together, okay? Same thing with the other side. You're going to fold it over into the center and then pull it back off to the side so that it creates so that it keeps those loops all together. Okay, so can you guys see that? How I have a circle with 2 little pieces hanging off? I mean, it literally looks like what you can see over here, right? So it's a little circle with 2 loops or 2 strands off to the side. Okay, how are we doing? Are you guys keeping up with me? Does that all make sense so far? Tell me in the chat box. Are we good? Do we know what's going on? Okay. So once you have this, all you need to do is you just need to sand off the edges because there's kind of this red coating on these. So you want to sand these off so that you can get to the copper part. If you don't have a like sandpaper, you can actually just use a nail file. So I've actually already done that, but you can see it's hard to tell. But this color right here is actually lighter than the red part. So this is the actual copper wire being exposed. If it's not exposed, it's not going to make a current very easily, and so it won't spin. Okay, so now the last thing that we do is we just stick the edges, these long parts of our copper circle, and we're going to go ahead and stick it, sorry, I actually need these to be a little bit higher, into these small loops that we made in our paper clips. Okay, so we're going to go ahead and stick this in between the small loops, and the magnet is going to be right underneath it, okay? So here we go. And then what you can actually do is you're going to go ahead and start it, okay? And you'll see that it actually begins to spin on its own. Okay, smiley faces, guys, if you can see that. Sorry, I'm going to move it over a little bit. All right, so you can actually see that it begins to spin on its own. So I can start it off and then it'll spin on its own, which it's having a little bit of trouble right now just because I'm holding it up. Oh, there we go. I believe in you. So sometimes it takes a little bit of fiddling around because of how heavy these things are. Hold on, let's see if I can try with the smaller one. Sometimes the smaller ones work better. Work. All right, there you go. You guys see how it's spinning on its own? I'm not touching it anymore. It's just spinning on its own. Come on, keep going. There we go. Pretty sweet, right? All right, cool. So why does this work? Let's go ahead and talk about why this actually works. Oh my gosh, it's going so fast now. Do you see it going, guys? It's amazing. All right, I'm going to go ahead. It's very hot now. Hot, hot, hot. I know, and it's very simple to make. So all you guys need, again, is, I'll write this in here, right? You need a D battery. Okay, you need some paper clips, metal paper clips. You need a strong magnet, and then you need some copper wire. Oops, and some tape and stuff, right? But it's super easy to make and it's a lot of fun to make, okay? But here we go. So the reason that this works, guys, is because what's happening here is all these little metal pieces are causing electric current to go through the circle, right? So the battery sends electric current through the paper clips into the copper wire, through the circle here, back out, and back into the battery. So what happens here is as we have current flowing through a coil of wire, remember that that actually creates a magnetic field, right? We learned this the last time I saw you, right? Is that when an electric current gets coiled up, it begins to create a very strong magnetic field. So this right here is literally creating its own artificial magnet. Okay, smiley faces if that makes sense. We're actually creating our own artificial magnet here. Super cool to think about. Again, this is like how car magnets work, right? Because you want to be able to turn them on and off. So I can turn this on and off by simply disconnecting the circuit. Now underneath we have a real magnet. And remember, because of those pushes and pulls between the north poles and the south poles, those are going to interact with each other and they're going to actually push each other. So this real magnet is actually going to interact with this artificial magnet, and they're going to push and pull against each other until this one begins spinning. Okay, so therefore we get some electrical current or electrical energy that then is able to actually turn this into motion, into mechanical energy. All right, give me a smiley faces if all of that makes sense. All right, it's pretty crazy to think about how you can actually create a motor by just mixing electricity and magnetism together. Cool, this is number 1 in your ticket. Give me a green check when you have it saved. I'm gonna go ahead and give you 45 seconds. Green checks all around. If you need it again, here is the link. Sorry, that's not the link, that's the copper. Sorry, here's the link to the attendance ticket. Go, go, go. No worries, good to see you, Andrea. Let me go ahead and get you your ticket really quickly. All right, anything you missed will be in the recording though, okay? All right, just waiting on a few more green checks. Alicia, Amir, let's see here, Ashton, Bradley, Dusty, Donnie, Dorian, Dree, Dylan, Edwin, Martina, Matt, Blossom, and Suji. Looking good. All right, guys, awesome. Okay, so that being said, now we're going to go ahead and take a look at our lab. So our lab is going to go ahead and help us figure out how could we actually create an even better motor, right? So I showed you a pretty simple motor, and it's not very strong, it's not very fast, and it obviously takes a little bit of fiddling with. But with other motors, right, we can actually make them really, really strong. So we're going to try to figure out how can we make a motor that spins really, really fast. So this is going to be a virtual lab. I'm going to go ahead and send you the link to your lab right now. Okay, you can either open it up now, or if your computer has issues having multiple things open during class, don't open it because then you'll get logged out. Just make sure you're paying attention and that you have the link for later. Okay, does everyone see though, if you have that lab open, once you open it, does everybody see the link to the virtual lab to where we actually do the experiment? Let me know in the chat box. Let me know if you're able to see that. Cool, cool, cool. All right, and it's working and everything? I know the last couple times it wasn't working, so awesome, it's working. Cool. Okay, so it's in the lab. I'll also send it to you right now. Here's the actual virtual lab direct link. But again, it is in your lab report, so if you lose it, it's always there for you. Okay, so what you're going to do is you're going to go ahead and open that up. And then if for some reason you see any Adobe Flash warnings, I'll tell you right now how to deal with them. So this one's super easy. This one that says click to enable, just click it and then allow your browser to use Adobe Flash, and that'll work. Or if you have this one that looks scarier, don't press the red button. The red button doesn't do anything. Instead, actually press where it says Activate Adobe Flash. I know it doesn't look like a button, but this is actually a button. Okay, so those are the two main problems with opening our virtual labs. If you're still having trouble, email me. But again, the main issue is usually you need to click Activate Adobe Flash. Okay. So what we're going to be doing is we are going to see how the number of coils in the copper coil affects the speed of the motor. Okay, so we're going to be looking at rotations per minute, or RPMs. We're going to see how the number of batteries, so if I had more than one battery, we're going to see how the number of batteries affects the speed of the motor as well. And then our last question is going to be, if we want to maximize the speed and get the fastest possible motor, how many coils should we, or which of the 3 coils should we use? All right, so we're going to have 3 coils, one with 9 loops, one with 12, one with 15. And how many batteries should we use? And our options will be 1 battery, 2 batteries, and 3. So we're going to test out each of these 6 instances, and then we're going to figure out which of those would be the best to figure out how we can make the motor go the fastest. Okay, give me a smiley face if all of that makes sense. Smiley face if all of that makes sense. Okay. I'm going to show it exactly to you. Okay, good. So in the first part, we're going to use just a single battery and test out each of the coils. And then in the second part, we're only going to use the 9-loop coil and test out each of the batteries. Okay, each of the numbers of batteries. All right, so let me go ahead and actually show you what this looks like. I'm going to go ahead and open this up for you. All right, thumbs up, everyone, if you can see my screen here. Looking good. All right, so let's see. Here's what your lab looks like. All right, and it's a super simple lab. There's no Google or anything that you need to do. So it's a very fast lab. Make sure you get it done today. That'll help your lab grade if your lab grade is low. Cool. All right, so you can see what we're going to do is question number 1 is we're going to use just 1 battery. Okay, so this is really important. Only use a single battery. And we're going to try each type of coil, and we're going to record the RPMs, the speed. Okay, so I'm going to go over here to where it says begin the lab. Sorry, again, the link right here is up here. So if you click on that, that should open it up for you. Okay, so I'm going to go over here and I'm going to click begin the lab and choose my gloves and click start. Okay, so here we go. Here's our lab right here. Okay, so I'm going to go ahead and I'm going to make this a little bit bigger just so that everyone can see it. Okay, so what you can see here is we have some different batteries here. Okay, you can see that we have some connector wires right here. We call them alligator clips. All right, we also have our different coils, and we have a magnet right here. Now, super important, in order for this lab to work, your batteries all need to be facing the same way. So if you click up at the black part of the battery, it's going to spin them so that the black part's on the right. If you click at the bottom, the gray part, it's going to spin them so that the gray part is at the right. So either way, it doesn't matter, okay? The results are a little bit different, but it's not going to change your grade or anything. You just need to make sure you choose which side of the battery you're going to pick up. Give me a smiley face if that makes sense. You need to make sure you choose which side of the battery to pick up and always pick up the same side, because if they're going in the wrong direction, if 2 of them are going opposite directions, your motor will not work. Okay, so here's what we need to do. In order to set this up, we need to first drop our magnet here at the bottom. Okay, so I'm going to click on the magnet just once and then come over here. And when you no longer see that red sign right here, it'll clear up. You can then click again and that'll drop it right in the center. Okay, thumbs up if you're following along, if that makes sense. Again, you don't have to have it open right now, but I want to make sure that if you do, that you understand what to do. Cool. All right. Next, what you're going to do is you're going to connect, okay, these alligator clips so that our batteries are actually connected to our motor. Okay, so we're going to go ahead and grab this alligator clip, and sorry, you can actually pick up the center right here. So click on the center and just drop it over here so that it's on the right side, and click on the center and drop it over here. Good. Okay. So then to drag the alligator clips, this is really important. You actually need to click and hold. Okay. So don't just click them once. You actually need to click and hold, and then you can drag it over and it'll attach up here at the top to where our motor will be. And then grab this one and hold it and attach it to the bottom at the batteries. And we need to complete the loop, so we need to do the other side as well. So I'm going to click and drag, click and hold and drag, click and hold and drag, and now everything is connected bottom to top. Okay, Smiley faces if we're following along, if we understand. Confusion faces if we don't. Want to make sure I'm not leaving anyone behind. Perfect. Okay, now we can go ahead and actually set this up, okay? So again, it says for part 1, we want to use one battery only. So I'm going to go ahead and grab one battery, and I'm going to actually, for me, I'm going to always pick them up from the black side, okay? So again, whichever side you choose, always pick them up from the same side, either the top black part or the bottom gray part, okay? So I'm going to click this, okay, and I'm going to drop it into one of the slots. It doesn't matter which one you drop it into. I'm going to drop it into one of the slots, all right? And then I need to go ahead, and it says with our one battery, we're going to first start off with our 9-loop coil. So I'm going to come over to my coils, pick up my 9-loop one by just clicking on it. Come over here. And as soon as you no longer see that red mark, you should be able to drop it over your magnet. So click and drop it. All right, and the last thing that you need to do is it always needs to start off with a push. So you're just going to get to where it has this little pointer finger that looks like this, and then you can click on your coil and it will begin moving. Okay, and it's going to actually measure the rotations per minute, the RPMs up here for you. Okay, so my result right now is with one battery and 9 loops, my RPM is about 145. Okay, it'll change a little bit, but I saw 145 for a while, so I'm going to go ahead and put in 145 here. Okay, make sure that you actually do this on your own because you might have different results based on how your batteries are and based on how your lab is loaded. Okay, give me a smiley face if you understand what to do now. Okay, so that's our RPMs right here. Okay, cool. The next thing that, yeah, so yours might be different, which is why everybody needs to do their own. Yeah, okay, cool. So the next thing is you can click this again. Actually, sorry, no. To pick it up, you can go over to the side of it and click it, and that'll pick it up. Okay, so make sure you drop it back where it was, otherwise you might get confused. Okay, it doesn't matter which battery you use first, no, and it doesn't matter which slot it's in either. It'll work no matter what. All that matters is that they do need to be facing the same way once we start using more than one battery. Okay, so then you're going to go ahead and grab the 12-loop one, okay, and you're going to drop that above the magnet. And again, we still only have a single battery, so using one battery, 12 loops. Then we're going to go ahead, click the coil, and it'll begin spinning. So now this one for me is about, what, 186, right? Again, yours is probably going to be different, all right? Sorry, you don't actually need to put RPM. The RPM's already designated up here next to speed, okay? All right, give me a green check if you understand part 1 so far. Okay, I'm not going to show you the 15-loop one because I don't want you copying data. So you should be able to do the 15-loop one on your own, right? So you would grab this 12-loop, drop it back to spot, grab this 15-loop, drop it over the magnet, click on it, measure the RPMs, and that should be your result right here that you would type in, okay? Now, part 2, we're going to focus on the batteries now. So part 2, we're always going to use the 9-loop coil, and the only thing that's going to change this time is the number of batteries. Okay, so I'm going to go ahead and reset this up. So let me drop this back over here. Okay, so now for part 2, we have to use the 9 loops. Okay, so I'm going to come back down here, put the 9 loops up here. Okay, and for the first part, we're just using one battery, okay, which I still have that one battery in there. So I'm going to go ahead and click on my coil, and we should get the same result. Okay, if your result is not the same between this part 1 where we used one battery, 9 loops, and this part 2 where we use 9 loops, 1 battery, which is the same thing, you did it wrong. So make sure you do it correctly, okay? Your first 2 boxes here should be the same. Okay, so the 1 battery, 9 loops should be the same as 9 loops, 1 battery. Smiley faces if that makes sense. Okay, so for me that's 145. All right, it can be slightly different, right? So it could be like 144, but it should be very close, right? It's the same exact setup as what we had in the first box. Okay? Now, the next one says still using the 9-loop coil, we're going to now put 2 batteries in. So I'm still using my 9 loops. I'm going to grab my second battery from the same side. So remember, I'm always grabbing from the top. You can always grab from the top as well, or you can grab from the bottom. Either one's fine as long as you grab from the same side always. So I'm going to grab here, and you'll see now it's facing the same direction, right? It looks the same as this one. If I were to grab it from a different spot, it would be backwards and my motor would no longer work. Okay, so my motor would stop working. So you need to make sure that you pick it up from the same side. So I'm going to pick it up from here, and they should be facing the same direction. Okay, now I'm going to go ahead. I have my 2 batteries. I have my 9-loop coil, double checking that. Good. click on the coil, and that's going to give me my new RPMs, right? Which for me is about 331, right? 331. Okay. All right, green checks if you feel good about that part. I'll show you how the third one's set up, but I'm not going to actually start it because again, I want you to get your own data. I don't want you copying. Okay, so I'm going to go ahead and grab my third battery from the same side so that they're all facing the correct way. Oh, sorry, I should still be using my 9 loops, and that's what it should look like. I'm not going to click on it, but when you click on it, you should get your data here. Okay? All right, so that's super, super easy, right? Give me a smiley face. Let me know in the chat box. Does that sound pretty easy? Does that sound pretty doable? Right? It's definitely not meant to be difficult to get this data. Okay? Now, the only last thing that we need to do is we need to analyze our data. Okay? So question number 3 is our analysis, and question number 3 is asking which of our 3 coils should we use and how many batteries should we use if we want to get the max speed of the motor. So to get to the max speed of the motor, you want each of these from the purple table and from the green table that has the highest RPMs. Okay? So you would take a look at your RPMs here, and whichever line has the highest RPMs, that's the loop that you choose, right? So if 12 loops has the highest RPM, you would use 12 loops. If 15 loops has the highest RPM, you would use 15 loops. Obviously, 9 loops is not going to have the highest RPM, okay? So then down here, you would choose whichever one applies, right? So 9, 12, or 15, okay? Or you could say the number of loops on the coil does not affect the speed. That's pretty unlikely, seeing as 9 loops and 12 loops actually have different results, okay? Then the next part is we also need to take a look at the number of batteries that we should use, right? So if 1 battery is the highest RPM, you would choose 1 battery. If 2 batteries is the highest RPMs, you would use 2. If 3 batteries is the highest, you would use 3. If the number of batteries doesn't affect the speed, which again, obviously it does, so that doesn't make sense, then you would choose this last one. But again, don't choose the last one because our data already shows that that's not accurate. Okay, so how many of these should you end up having clicked then? Tell me in the chat box, how many check marks should you end up with? 1, 2, 3. You should end up with 2. 2. You should tell me the number of coils, so you should click one of these 4, and then you should tell me the number of batteries, so you should click one of these bottom 4. So the total number of checks you should have is 2. Give me a smiley face if that makes sense, because you're telling me which of the 3 coils, so choose one of these top 4, and how many batteries, choose one of these bottom 4. So 2 in total. Cool, and that's it. That's your conclusion, and you will have figured out which one gives you the fastest speed. You could also, even if you wanted to, you could actually test them out yourself. So if you choose whichever ones you choose, if you want to double check it, you can actually test it out. So if you think that 12 loops and 3 batteries gives you the fastest speed, you could actually go ahead and test it out and put on 12 loops and 3 batteries and see what happens, okay? Which that's not the correct answer, so don't choose that, okay? Definitely take a look at your data and choose based on your data. Okay, how are we feeling about that? Do we feel like we can be successful on that? Do we feel confused? Go ahead, type in the chat box. How are you feeling about that? I don't want to leave anyone behind. The recording will be up, so if you miss anything, it'll be in the recording. Cool, so easy peasy. Awesome, guys. All right, so today we demonstrated how electricity and magnetism are related and can actually be used in a motor to create motion, to create mechanical energy. Okay, so you're going to go ahead, when you log off, I want you to continue working on the 9B lab. It is technically due at 4 o'clock. I do recommend try to get it done by 4 o'clock because it is a really simple lab to finish. So make sure, try to get it done today. But again, I care more about it getting done correctly. So I'll be grading them as they get turned in, and I'll enter zeros at the weekend. Actually, I'll probably enter zeros a little bit earlier because I want you to have an accurate grade for your final exam. So I'm going to enter zeros in by tomorrow night, okay? So make sure that you, sorry, that's not it. Sorry, Justin. Okay, I'm going to enter zeros in tomorrow night just because we have the final exam coming up and I want you to have an accurate grade, okay? So make sure to try to get it done today, okay? That's all I need to say. So here's your last word. Thanks so much, everyone, and I will see you later. Last word for today is current. All right, that's going to be number 2 in your ticket, and I will see you all later. If you missed anything, it will be in the recording. Bye, everyone. Have a great day. Thanks for having a great start back from spring break. Bye, Tariq. Bye, Israel.